Okay, on to page 8, which is devoted solely to the scatter plot. The reason it's such a big page or such a big problem for one page is because it takes a really big graph to make a scatter plot. But after you make the graph, it's usually a relatively easy thing to do to really figure out the rest of it. So what I'm doing right now is I'm hoping that you're looking at your paper and you can see that the x and the y values are all positive numbers, which means that when we go to make the graph, and it's important when you do this, when you go to make the graph, basically what you're saying to yourself is, I don't need anything other than that top corner of the x and y axis. So it means basically I'm focusing on one thing. And I don't need any of the negatives down here. Okay, the second thing is to look at your x-axis and say to yourself, okay, well, it looks like the lowest number I have is 2, and the highest one is 28. So it means that I have to get numbers as low as 2 and as high as 28 to fit on this x-axis. So if you have enough room, you could scale it by 1s if you feel like. But I think in this case, it might be better to try to do it by 2s. And that's fine, as long as you label it correctly. So I'm going to not label every single line here with 2, 4, 6, 8, 10, and so on. I'm just going to mark off checkpoints. So here's 2, 4, 6, 8, 10, which is right here. 2, 4, 6, 8, 10. So I might go ahead and actually put a 10 in there so I know where 10 is, just to keep my graph looking neat. But then 12, 14, 15, 18, 20, 22, 24, 26, 28, 30. That basically takes me through all of the points I'm going to need on the x-axis. On the y-axis, it goes from 3 all the way up to 41. So again, doing this by 2s might be a bit of a pain, so maybe by 5s is better. Or in this case, I think, since I do have a lot of room here, I can probably get away with 2s and be all right with it. So 2, 4, 6, 8, 10, 12, 14, 15, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. I have to go up to 41, which it looks like it will fit right up here, so we'll be good. So I have the graph scaled correctly now, and I don't have anything to label other than this is the y-axis and this is the x. So we're not dealing with things like time or whatever. It's just something simple, x and y. So it says make a scatter plot, which means that you actually have to go through and plot all of the points that you're given. So I'm hoping that you guys can plot a point by now. So what I'm saying is that point 2, 3 is the one I'm going to graph. So over 2 and up 3, which happens to be right here. So I'm going to go ahead and plot the rest of these. I'm not going to make you wait and watch me do that. So I'm going to pause this for a second while I plot them, and I'll come back on in just a moment. Okay, so now that I have all my points plotted in, now I need to do the part that everybody seems to struggle with so much, which is drawing a best fit line. What I'm looking at here is there like a general trend to my data? If you were to lay your pencil on it, I think you see that that trend is basically right here. And with these couple of points, they may be a little bit off from where we ideally want them to be. So basically that trend is running right through here. So that's where I'm going to draw my best fit line, through that general trend. So you want to use a ruler to do this and make it as straight and neat as possible. So I would say something like that seems pretty reasonable. In fact, I might even angle this just a little bit more. Not much, but a little bit. I kind of like that right there. Now, one thing you want to make sure to do when you do these problems is make sure that your graph actually does touch the y-axis. So I'm going to actually extend mine just a little bit, like that. So sometimes your line really will touch at 0, and sometimes it doesn't. It doesn't matter. As long as it touches the y-axis, that's what you want it to do. So the way I scaled my graph and my estimating of my best fit line might be slightly different than yours, and so as a result, you may end up with an intercept that looks a little bit off. And that's due to human error and basically estimation. It's okay, as long as you get the process down, I think you'll be all right. But the key is to try to draw your best fit line as much in the center of the data as possible, and don't worry about points that are way off from the other. So making the scatter plot is the first thing we did. That was number 1. Number 2 is to find the y-intercept. So in this case, my y-intercept is where it touches the y-axis, which is why I made sure I drew my best fit line to do that very thing. In this case, it happens to touch at 0, so my y-intercept is really 0. Now the next thing is the slope. And you kind of have to do these steps in order because basically you can't do step 4 right in the equation without doing steps 2 and 3. So I need to find a slope. So what I'm looking for is a coordinate point somewhere on my line that is easy for me to spot. It does not have to be, in fact it really shouldn't be, any of the data points that you have. So I'm looking for something that's easy to spot, and I think I see one right here. So what I'm saying is to find the slope, I want to know what it takes for me to get from my y-intercept to that other point I found. So basically, I'm counting upward and then to the right. Remember that I did these by 2, so I'm not counting blocks, I'm actually counting numbers. So I'm going up 2, 4, 6, and right 2, 4. So I went up 6, so the rise is 6, and the run, I went 4 to the right, which is 6 over 4, and that's going to be 3 over 2. So that means for step 4 then, to write the equation, it's a y equals mx plus b kind of equation, where the m is the slope I have here, and the b, the y-intercept, is 0. So I'll write it there for the moment, just to show you that that's what it looks like. But in reality, we would write this equation as simply 3 over 2x, and not write the plus 0. Number 5 says, what type of correlation is shown? I think everybody had a pretty good understanding of this. This graph is clearly going upward. It's definitely a positive correlation. Finally, number 6 says, predict a value for x equals 50. So when it says predict, it means don't use your graph. It doesn't mean look at a data point. It means look at your equation and see what happens. Now that you have this equation, what would happen if x were 50? So you're using your equation to determine a value. So this value could be x is 1,000 if you wanted it to be. Some number way bigger than what you have on your graph. The point is to use your equation to determine what the value will be. So I'm substituting in x equals 50, putting a 50 in for x. I'm going to get an answer for y. So that is 50 times 3, which is 150, divided by 2 is 75. So this is how you deal with a scatter plot. Also, on your test, once in a while, you'll get a scatter plot that asks you to say something or describe the relationship. So we could call this number 7, describing the relationship, which is not really on your paper. It would be occasionally on a test, though. So let's look at this. Describing the relationship is something that we can just kind of talk about. We don't have to write it down. But here's what I would say. I always look at the x-axis and I say, as x increases, what happens to y? Well, okay, when x was 0, y was 0. Well, when x is 20, it looks like y is somewhere around 30. So obviously, when x goes up, y goes up. That's the relationship. As x increases, y increases. That's the end of the scatter plot.